Hello students, supposedly this problem will be given as one of the problems in the summative, midterm summative assessment. But I decided to change it and so that you can review with the squared property of parabola. This is a problem on an arc structure, and the concept of squared property of parabola is emphasized here to analyze this problem in equilibrium. We can also consider this as a 2D frame. So the analysis would be that of a frame, but each portion of the arc is a 3/4 body because the ends are pins and there's a force in between. But I will not use that concept. I'll just use the free body diagram of the entire system and draw the FBD of a segment of this arc from one point to the interior hinge B here. So drawing the free body diagram of the entire system, let us just assume that the external components of the reactions are all directed in the positive directions as shown. So this is now part of the free body diagram. Whatever is the result will not be changed because the free body diagram, the reaction components are indicated in this FBD of the whole system. So considering this whole system, we sum up moments about C, considering clockwise positive. But before that, let's compute the vertical distance of the 50 kilonewton load from B and the 80 kilonewton load from B, vertical distance, as well as C from B, because it is stated that the interior hinge is the vertex of this parabola. Let us resolve 50 into two components. The horizontal component is 50 sine 60 degrees, and that is 43.3 kilonewtons rightward. And the vertical component is 50 cosine 60, 25 kilonewtons downward as shown. So summation of moments about C equals 0, clockwise positive, after squared property of parabola, which is, I'll call this Y1, vertical distance of 80 kilonewton loads from B, Y2, and vertical distance of point C from B, Y sub C. So by squared property of parabola, Y1 as to 3 square equals Y2 as to 4 square equals Y sub C as to 6 square, and it is equal to 4 YA as to 4 square. So y1 as to 3 square equals y2 as to 4 square equals y sub c as to 6 square equals 4 as to 4 square. So y1 is equal to 2.25 meters, y2 is 4 meters, and y sub c is 9 meters. So we can now set up the first static equation, summation moments about c equals 0, clockwise positive. So ax times 5, where 5 is yc9 minus 4, plus ay times 10, 4 plus 6 is 10, plus 43.3 times quantity 9 minus y1, 9 minus 2.25, then minus 25 times 3 plus 6, 9, minus 80 times 2 equals 0. Simplifying 5ax plus 10ay equals 92.725. So I'll call this equation 1. Then considering segment AB, we sum up moments about B, and this is the free body diagram. Naming of the components of the reactions at B is not important because we don't need to solve these internal components of the reactions at B. So summation of moments about B equals 0, this time counterclockwise positive. So we have AX times 4 minus AY times 4 plus 43.3 times y1, which is 2.25, plus 25 times 3 equals 0. So that is ax times 4 minus ay times 4 plus 43.3 times 2.25 plus 25 times 3 equals 0. Simplifying, 4ax minus 4ay equals negative 172.425, and let's call this equation 2. Solving equations 1 and 2 simultaneously, we get AX equals negative 22.56 kilonewtons. So that means it should be leftward. And AY is equal to 20.55 kilonewtons. We then solve for CX and CY. Let's go back to the whole system, free body diagram of the whole system. Summation of moments about A this time, considering counterclockwise positive. So Cx times 5, again the vertical distance between A and C is 5, 9 minus 4, plus Cy times 10, then minus 43.3 times quantity 4 minus 2.25 minus 25 times 1 minus 80 times 8 equals 0. 80 times 8 equals 0. Simplifying, 5cx plus 10cy equals 740.775. Call that equation 3. Then we draw the free body diagram of BC, and we sum up moments about B equals 0. And again, by principle, action-reaction, forces are equal but oppositely directed. Bx will now be rightward and By downward, but again, they are not important. We sum up moments about B equals 0, uh, counterclockwise positive, so Cx times Yc, Cx times 9, plus Cy times 6, minus 80 times 4 equals 0. Solving for, or simplifying this equation, 9cx plus 6cy equals 320. Call that equation 4. Solving equations 3 and 4 simultaneously, we now get cx equals negative 20.74 kilonewtons and cy equals 84.45 kilonewtons. So finally, let's validate these answers by checking our answers if these reaction components as well as the loadings will be in equilibrium. So summation forces X equals AX, which is negative 22.56 plus 43.30 plus CX, which is negative 20.74, and it is 0, so that's fine, it's okay. Summation versus y equals AY 20.55 plus CY 84.45 minus 25 minus 80, and that is also 0. So that means our answers are correct. So that's it for this video.